For question number 7, we have a capacitor of capacitance 2.5 microfarad, and then it is fully charged by a battery of 12 volt. It is then connected to a resistor of resistance 2 mega ohm. So what is the charge on the capacitor after 40 seconds? So when the capacitor that has been fully charged is connected to a resistor, what is happening is it is trying to discharge the capacitor. Okay, so this is discharging process using a resistor lah. Okay, so the equation that we will be using is gonna be q naught E negative T over RC lah. So first we need to find the q naught, value of q naught, the maximum charge before it is connected to the resistor. So this is just CV, which is equal to 2.5 times 10 negative 6, 12, which will give you 30 microcoulomb. Okay, so dapat sudah tu, baru kita boleh substitute into this equation here. 10 negative 6 E minus T is 40. R is 2 times 10 to the power of 6, which is mega. And then this is 2.5 10 negative 6 over the time, which is 40 seconds. Just gonna put it a bit down here. So kira lah tu kamu akan dapat the amount of charge after 40 seconds is 1.01 times 10 to the power of negative 8 coulomb. Okay, so it reduces from 30 microcoulomb to 1.01 times 10 to the power of negative 8 coulomb. Okay. Yes, okay. Now we have to determine, now we look at question B, where the capacitor with charge Q is connected across a resistor for 76 seconds. The charge decreases to 0.05% of its initial charge of Q naught. So this is equal to 0.05 divided by 100. That's gonna give you 0.0005 Q naught, okay, of its initial charge. Now we have to determine the time constant, and we know the time constant is equal to RC. So di sini kita masih lagi boleh guna Q equal to Q naught E negative T over RC. So why do I use this equation, not the charging process? Because the question has already mentioned that the charge decreases to 0.05% of its initial charge, meaning this is a discharging process. Okay, so substitute all the values equal to Q naught E minus 76 seconds over tau, which is what we are looking for, and this can be cancelled, so we can then ln both sides. Okay, so this will be negative 76 over C, which will then give you the capacitance to be I am down. Sorry, this is thou, which will then give you the time constant to be equal to 10 seconds, ataupun I think it was 9.99 seconds if I'm not mistaken, but then you just round it off to 10 seconds lah. Okay, alright, so that is on question number 7.